Hello viewers, in this tutorial I discuss about double sideband amplitude modulation. So, amplitude modulation is characterized by an information bearing carrier amplitude like A of t, clear? And that is a linear function of the baseband message. So, the baseband message signal is indicated by m of t. At the same time, the carrier frequency, which is indicated by omega c, and the phase theta c remain constant. Okay, so that's time carrier frequency and phase is always constant, these two, mind it. So we can assume theta c equals 0 without loss of generality. So if the carrier amplitude A is made directly proportional to the amplitude signal m of t, then modulated signal is m of t cos omega c t, clear? That's the modulated signal. First time for the double sideband amplitude modulation must be the signal will be modulated, and then m of t is equal to m of f, clear? So in that equation it will be simplified with m of t cos, we know that m of t means m of t cos 2 pi fct equal half. That's the value we simplified in last tutorial here. That's okay. So half m of f plus fc plus m of f minus fc. So recall that the m of f minus fc is m of f shifted in the right by fc. Okay, and in this system, so the process of modulation shifts the spectrum of the modulating signal is the left and to the right by fc. Okay, and note that if the bandwidth of m of t is b hertz, like m of t is b hertz, we just note that, and then as seen that the signal has bandwidth of 2b hertz, So in this system, the relationship of b to fc is of interest, like the figure will be. Here m of t, that means modulating signal, and next one is m of t cos omega c t, that is modulated signal, that is modulating signal, and that is modulated signal, and here the cos omega c t, which is carrier. So the m of t cos omega c t, that's the signal will be okay. That's okay. Here that is m of t cos omega c t, and that's the signal is m of t, message signal. Here minus m of t cause its negative side, and that's the time domain. Okay, so note that the practical factors may impose additional restrictions of fc for instance in broadcast application. A transmit antenna can radiate only a narrow band without distortion. Okay, and broadcast band AM radio for intense with B equal 5 kilohertz. Okay, B equal, that's the B equal 5 kilohertz, and the band of 50 550 to 100 1006 kilohertz. Okay, for the carrier frequency. So that's the double side band amplitude modulation. And thank you everyone, and subscribe my channel. See you in next tutorial.